Hi folks, so today's video we're looking at the products of electrolysis from solutions. So it's moving directly on from the previous video on electrolysis, so make sure you've watched the electrolysis video before this one. As always, we're going to start with a quick quiz. So if you want to pause the video and have a go at these questions, and then I will restart the video, or then restart the video when you are ready to solve it. So I'm going to restart the video and go through these questions now. Make sure you've actually had a go at them, right? So what is reduction? If you remember, the key to this is remembering the acronym oil rig. So it's not actually got anything to do with oil rigs, but it stands for oxidation is loss of electrons, reduction is gain of electrons. So the answer for what is reduction, it is gaining of electrons. What charge is the cathode? So the cathode is negatively charged. If you remember, cations are positive, which means that opposites attract. So cations are attracted to the cathode. So if cations are positive, the cathode must be negative. So if you remember, cations. So cations are positive, which means the cathode must be negative. The opposite of those, so we've got anions. So anions are negative, which means the anode must be positive. So what charge is the cathode? It's negative. What happens at the anode? So what happens at the anode? If you remember, in the previous video I went through this. Oxidation, A for anode, A for oxidation. The other one is reduction. Reduction happens at the cathode. So what happens at the anode? Oxidation. What's an electrolyte? It's an ionic compound, but it needs to conduct electricity, which means it either must be molten or in solution. So an electrolyte is an ionic compound that's molten or in solution. And what is electrolysis? It is decomposing, breaking down. It's decomposing an electrolyte. Might run out of space. Decomposing an electrolyte using, sorry, terrible handwriting. Using a direct current. So using electricity, that is a direct current. Okay. So today, products of electrolysis from solution. So the solution bit is the key to this question, right? Because if you've got electrolysis of molten things, so I'll just do a very quick recap. If you're doing electrolysis of a molten electrolyte, so if we look at lead bromide, for example, so molten lead bromide, so lead bromide, and they would tell you this in the exam, Pb is lead, so lead bromide is PbBr3. The ions that is made of is Pb3+, so it's got a charge of +3, and then it's 3 lots of Br-. So Br-, you've got an ion that's got a charge of -1. You've got Pb that's got a charge of +3, but the charges have to balance, so it means there's 3 of these Brs, right? Br-, Br-. So we've got 3 Br-, 3 Br-, and 1 lot of Pb+. And they hang around together as PbBr3, which is lead bromide. So if you make it molten, then you've got all of these. We've got our circuit, we've got our electrodes. Let's make this one the anode, that one the cathode. So we've got all these ions in solution. So the Pb3+ goes there, and then the Br- goes there, and we separate them out. So we make lead, and we make bromine. Not bromide, bromide when it's an ion, but we make lead and we make bromine. And it's easy because the only ions there, the only positive ion is lead and the only negative ion is bromine. Nice and straightforward. So let's try another one. If we had molten sodium chloride, so molten sodium chloride, sodium chloride is NaCl, and the ions involved, sodium is in group 1. If you look on a periodic table, it means it needs to lose 1 electron, so it's Na+. Chlorine's in group 7, needs to gain 1 electron, so it's Cl-. That's all we've got. So if we melt it, we've got Na+, Cl-. What would you make if you did this? Well, you're going to split this up. So you make sodium and you make chlorine. So any molten product is really easy because you're just splitting it up, and so you make the positive one and the negative one. So if we had, I don't know, copper iodide. So I'd like you to just have a guess what this is going to make, and I'll go through the answer in 3 seconds. Yep, so it splits up, and hopefully you got this right. So it splits up, so you get copper, and then you don't get iodide, you get iodine. Yeah, so you get copper and you get iodine because we've broken that apart. So the fact it's molten, there's only 2 things there, so you have to split those up. It becomes more complicated. So the title for today was talking about solutions. So it becomes more complicated if we're talking about a solution, because when you're talking about a solution, it means you haven't melted it. It means you've dissolved it in water. So if we were looking at copper chloride, so copper chloride, but not liquid, which would be molten, but aqueous. So we've dissolved it in water. We've made it slightly more difficult because in that solution, you've got something else now. You've got the water. So you've got copper, which is Cu2+. You've got 2 lots of chlorine, which is Cl-. I'm not going to balance it because I'm going to talk about this in more detail. Obviously, water, you know, water is H2O, but a tiny bit of that water does split up. And when it splits up, it makes a H+ and an OH-. So we've got some extra ions in here. It's not just as clear cut as copper and chlorine anymore. Because it's in solution, we've got a little bit of H+ and we've got a little bit of OH-. So when we do electrolysis on it, so we've got the cathode, which if you remember is negative, and we've got the, let's do this in a different colour, and we've got the anode, which if you remember is positive. So then that and that are both attracted there, and do it in a different colour. So that one and that one are both attracted there. So they both go there, but which one actually reacts? Because only one of these can react. So are we going to get chlorine, or is the OH going to react? And then over here, are we going to get copper, or are we going to get hydrogen? So just to explain how that works, and I will come back to this. Looking at the positive ions first of all, you need something called the reactivity series. Reactivity series. And so if I put the most reactive at the top and then the least reactive at the bottom. Okay. So the closer to the top you get, the more reactive it is. Further down, the least reactive it is. So we're going to have K, which is potassium. I'm not going to write out their full names because you'll just be afraid just watching me write them all out. But K is potassium. These are all on the periodic table. Na is sodium. Li for lithium. Ca for calcium. Mg for magnesium. Al for aluminium. I'm going to do this one in a slightly different colour. So it's C for carbon, because carbon isn't a metal, but it become clear later on why I've put it in there. And we've got Zn for zinc, Fe for iron. Then also not a metal, but I put it on there. We've got H for hydrogen. And then, you know, we're right at the bottom, not particularly reactive now. We've got Cu for copper, Ag for silver, and then Au for gold. And hopefully, you know, like silver and gold, like they're really not very reactive at all, right? So this is our reactivity series. Remember, we've got hydrogen in here. And the rule is when you're doing electrolysis, if the metal is more reactive than hydrogen, so if it's more reactive than hydrogen, then you make hydrogen, because the metal's more reactive, so it's like, yeah, we'll let you make hydrogen instead. If it is less reactive, then you make the metal. Okay, so if we come back over here, let's look at the cathode first. What has actually gone to the cathode? We've got copper and we've got hydrogen. So if we go back to our reactivity series, we can see copper is less reactive than hydrogen, which means we will make the metal. So we're going to make copper. So we've got Cu2 plus is the one that's going to react. It just means the H plus is going to sit around and do nothing. So we've got Cu2 plus is going to do the reacting. If you remember what actually happens at the cathode, so at the anode it was oxidation, at the cathode it's reduction. Yeah, so it's going to be reduction. And what is reduction? Oil rig, reduction is gain of electrons. So this is going to gain electrons. So it's going to gain 2E minus. This is a half equation that we're doing. So it's got 2 plus, which means it needs to gain 2 electrons. So it's going to make Cu. So it's going to make copper. So when you do copper chloride electrolysis, so copper chloride solution, at the cathode, you get copper. At the anode, so what's going to happen? Are we going to make chlorine, or is this ion going to react instead? The rule there is a little bit easier. I'll come back to this board because I want to, actually, I'll use a different one. So if I use the phrase complex ions, right? So complex ions, that's a simple ion is just made of like one particle. A complex ion is made of, it's more complicated, it's made of more than one particle. So as an example, so if I had complex and I put simple over here, simple ions. So simple ions as in like Cl minus or Br minus or iodine I minus. Whenever you've got these, you get the element. So Cl minus, you get chlorine gas. Br minus, you're making bromine. you're making iodine. They go around in pairs. That's a separate video on covalent bonding. I'm not going to go into that here. But if you've got a simple ion, they just make the element of it. If you've got a complex ion, so as an example, so if you've got a nitrate ion, which is NO3 minus, just to explain what that is nitrogen bonded to 3 oxygens, but the whole thing floating around together has a charge of -1. This is why it's a complex ion. So that's a nitrate ion. You've also got to know about a sulfate ion, which is SO4, 2-. So that's 1 sulfur and 4 oxygens all joined together. Don't stress about how that works, but just know that it's SO4 and all together it's got a charge of -2. Or if you've got a carbonate ion, which is CO3, 2-. These are complex ions. If you've got these, you don't make the elements when you do electrolysis. So it's like chloride ion mixed with, you make oxygen, you make O2. Just to explain, I'll explain why that is in a second. I'll put that to one side for a minute. Let's go back to our answer here. So, got to remember, so the ions we've got to choose from, we've got the OH or we've got the Cl. And so our rule was, if you had a simple ion, you just make the element for it. So we're going to have Cl minus. What happens at the anode? You remember, at the anode it's oxidation, and oxidation is loss of electrons. So that Cl minus is going to lose an electron. So it's going to be Cl, and then it's lost the electron, E. And again, covalent bonding video a while back, Cl goes around in pairs, which means we need 2 of those, because it's going to go around as a Cl2. If we're going to have 2 chlorines, it must mean we would have had 2 of those ions. And then if that means we've got 2 negative charges, which means we would have needed 2 of those. So if you do electrolysis of copper chloride solution, you make copper and you make chlorine. Okay. Right. The next solution you need to know about, because there's 3 of these. So it's not going to be copper chloride solution. It's going to be sodium chloride solution. Right. So sodium chloride solution. So what have we got in sodium chloride solution? Well, we've got Na plus, we've got Cl minus, but it's in a solution. So we've also got H plus and OH minus. Remember where those have come from? Because you've got water, which is H2O, and a little bit of the water is split up to make those. So we've got those 4 ions in there. So cathode. Remember the cathode is negative. So then we've got the anode. The anode is positive. So what's going to go where? This one attracts the negative ion, so we're going to get chlorine and OH. This one attracts the positive one, so we're going to get sodium and hydrogen. So let's do the cathode first. Cathode is reduction, and then oil rig, reduction is gain. So we're going to gain electrons. But which one of these 2 react? So remember, for the metal, we need to go back to our reactivity series. So Na, sodium, all the way near the top. It's definitely above hydrogen, which means we don't make the metal, we make hydrogen instead. So we're going to have H plus, and we know we're going to turn it into hydrogen, which is H2. Remember, cathode is reduction, and oil rig, reduction is gain, rig, reduction is gain. It's going to gain electrons. So we're going to give it an electron to cancel out the plus. So H plus, we give it an electron, that would technically make H, right? But again, covalent bonding doesn't go around as H, it goes around as H2, which means we need 2 hydrogens, which means we will need 2 electrons. So we have made hydrogen. Yeah, hydrogen's a gas. Right, what's happened at the anode? This is exactly the same as the one we just done. I know, so copper chloride, I get this side's different because instead of getting copper, we get hydrogen this time. We don't get sodium, we get hydrogen. But the chloride is exactly the same as before. So when we look at our little list, chloride's a simple ion, so we're just going to get Cl2. So it's exactly the same as what happened before. Yeah, Cl minus. Remember, anode is oxidation. Oil rig, oxidation is loss of electrons. So it's going to lose electrons. It's just going to go to chlorine because it's lost that electron. And then it's covalent bonding, so it's Cl2, which means we need 2 of those. And then that had 2 minuses, so we need 2 of those. So we're going to make chlorine. Right. Okay. Next one. So the next one you need to know about is electrolysis of sodium sulfate solution. There's sodium sulfate, and then there's, hang on in there because the next one's much simpler. So we've got sodium sulfate solution. So it's aqueous, right? That is made of sodium, which is Na plus, and sulfate, which is SO4 2 minus. You know, if we were balancing that, it would be that, because sodium sulfate is Na2 SO4, because this ion's got 2 minuses, which means we need 2 of these to be a plus. But for this part, we're not interested in how many there are, just the charges. So we've got sodium, which is Na plus, and sulfate, which is that. Remember, it's taking place in solution, so it's in water, which means some of the water split up. So we've got H plus and OH minus. So same as before. The cathode is negative. The anode is positive. So positives go towards the negatives, so we get those two there, which means these ones are attracted here. Right, and there's not loads of these to remember because this is a pattern, it's the same as before. We've already done what happens when you've got sodium and hydrogen. It's exactly the same as the previous one when we did sodium chloride, because we're dealing with either sodium or hydrogen. If you remember from when we looked, sodium is more reactive than hydrogen, which means we're just making hydrogen. I'm not going to go through this, I'm just going to write it because it's exactly the same as the previous one. H plus is at the cathode, so it's reduction, which means oil rig. Reduction is gaining electrons. It's gaining that. And if you remember, it was H2, which means we need two hydrogens, which means we need two of those, and we're making hydrogen. That is exactly the same thought process. It's a carbon copy of the previous one. The previous one was sodium chloride, but we don't care about the other part. It was sodium, so it's exactly the same as before. This part is sulfate. We haven't dealt with sulfate before. If we look at this, we just remember sulfate, it's a complex ion. We're going to make oxygen. And if you want to just remember that, that's fine. You can just remember it's a complex ion. We're making oxygen, which is O2. That's fine. This half equation is the trickiest one. Don't stress about it if you don't get this one. Just remember, all complex ion, it's oxygen. So if you want to just, don't stress about the next 40 seconds. Try and follow along, but don't stress. Because instead of this making it, it's the OH that reacts. And so you get OH minus. And it's going to make oxygen, because I've already told you it's making oxygen. But we know it's not going to make hydrogen, because hydrogen's being made over here. So the only other thing we can make with these ingredients is water. So we're going to make H2O. And then that gives us an odd number of oxygens, because we've got 2, we've got 3. This isn't going to work. We're going to balance this out. Again, this is like borderline A-level chemistry, this thing, so don't stress out too much about it. But the bottom line is we need 4 OHs. Because if you look, so we're going to have 4 hydrogens, and over this side we've only got 2, so we need 2 of those. And if you look, so then we've got 4 oxygens, and over here we've got 2 oxygens there, and 2 lots of 1, so we've got 4 and 4, so that works. We've got 4 hydrogens, and 2 lots of 2, so we've got 4 hydrogens. The only thing we haven't got, we've got 4 minuses over here, and we haven't got any minuses over here yet. And if you remember at the anode, so this is gaining electrons because it's reduction. So this must be losing electrons because it's oxidation. So it's going to have lost those 4 electrons. So I'm just going to squeeze this in. It would be 4E minus. I'm just going to rewrite that so there's a bit more space so you can see what's happened. So we've got 2 lots of H2O plus an O2 plus 4E minus. So that is much more complicated, so don't stress too much about that. Just remember, complex ions, they just make oxygen. This is why, because the OH from the solution, 4 of them get together, they make 2 waters, they make a bit of oxygen. So it's that oxygen is produced as a gas. The water just goes back into the solution because it's a solution. So but like I said, just remember, complex ions, you're going to get oxygen. Right. Last one of these, and this is water that has been acidified with sulfuric acid. So because water pretty much hangs around as H2O, it doesn't split up too much, so it wouldn't conduct electricity. Pure water does not conduct electricity. Again, back to the covalent properties video if you don't understand that. But when you acidify it with a bit of sulfuric acid, it means it splits up a bit more. So you're going to have a H plus ion, you're going to have an OH ion because of the, you know, those two together are what makes you water. And then sulfuric acid. So sulfuric acid is H2SO4, which means you're going to have H plus ion from the acid. Well, we've already got that, so I'll just cross it out because, you know, we don't need it twice. And we're going to have a sulfate ion from the sulfuric acid, which is SO4. 2 minus. Again, it's a pattern. You've already done this. Cathode. Cathode is negative. So that means, and then anode. So these two go to the anode. That's the only one that's going to the cathode. This makes it nice and easy. Only one's going here. So we're definitely going to get hydrogen. I mean, it's pretty straightforward. You split up water. If you do electrolysis, which is splitting up something on water, you're going to get H2O. You're splitting up, you're going to get hydrogen and you're going to get oxygen. Spoilers. So the H plus. What I'd like you to do is pause the video now, and I want you to tell me what's going to happen at the cathode in terms of, is it oxidation or reduction, and I'd like you to have a go at writing out the half equation. So I'll give you 5 seconds. 4, 3, 2, 1. Right, so hopefully you've got cathode is reduction, and then oil rig, because it was reduction. Reduction is gaining electrons. So hopefully you've got your H plus, and it's gaining an electron. E minus, and it makes H, but it's got corona pairs, which means we need 2, which means we need 2, which means we need 2. So it's reduction, it's making that, so it's made hydrogen. Again, simple answer here. That's a complex ion. Whenever you have a complex ion, you're going to make oxygen. So you're going to make O2. That's fine if you just want to leave it at that. If you want to have a go at the half equation, that's fine, because it's, you know, it's this one that does the reacting. If you want to have a go at the half equation, it's the same as the one I've just done in the previous question, so that's fine. So you can pause the video now and have a go. Right, so hopefully you've got the anode. It is oxidation. Remember, oxidation at the anode. And then for oil rig, oxidation is loss of electrons. So you've got OH minus, and we make water, H2O and O2, and it's had to lose electrons, so it's lost an electron there. And then we need to balance it, which means we need 2 of these, 4 of these, and then we've got 4 minuses, so we must have a 4 there. And that's it. That is electrolysis of solutions. Well done for sticking with it.